detectors. So as you have studied earlier, the silicon photodiode detector, it consists of a reverse biased PN junction, which is formed on a silicon chip. So that reverse bias that will create a depletion layer that reduces the conductance of the junctions to nearly zero. If the radiation is allowed to impinge on this chip, if the radiation is allowed to impinge on this chip, just to go through this, just to look at this diagram. The generation of holes and electrons in the depletion layer, and this causes a current which is proportional to the radiant power. Okay, causes the so whatever the current produced is proportional to the radiant power. And this photodiode is more sensitive than the silicon diode detector is more sensitive than vacuum phototube. Okay, but less sensitive than a photo multiplier tubes. And these photodiodes have a spectral ranges of from about 190 to 1100 nanometer. Right. So this is one type of photodiode detectors which you have studied earlier. Next comes the linear arrangement of these photodiodes acts as a linear photodiode arrays. Okay, so you have the reverse biased PN junction diode, which is being fabricated on a single silicon chip, right? So the number of the sensing elements in a chip can vary from 64 to 496, 4096. Okay, so you can have these number of sensing elements. So the radiation which is impinging on these photodiodes, the array of photodiodes, you will get an equivalent electrical output voltage. This produces an output voltage where this can be pre-amplified and can be read in a meter. Okay, so this is the photodiodes being arranged in the form of an array. Forms a linear photodiode array. Next comes the thermal detectors, which we have seen earlier in your previous courses, right? So the photo transducers or photo transducers are not generally applicable for the infrared region of the spectrum, cannot be used. So because this infrared energy, infrared radiations lacks energy to emit electrons. Okay, so hence thermal transducers can be used for this range of electromagnetic spectrum. So these thermal radiations from, say for example, in a human body, whatever be the IR radiations being emitted can be captured. So that's how they designed an IR thermometers. Okay, based on that principle, the IR radiations being emitted will have some heat energy content in it. So based on that heat energy, you have studied in your previous courses about the thermocouples, right? So those thermocouples are temperature transducers, which works on the principle of a Seebeck effect. When two dissimilar metals are joined together to form two different junctions, and EMF is developed across the junctions, right? A voltage develops between the two junctions that varies with the difference in their temperature. This is the principle of a thermocouple. And these thermocouples have high stability. And the output voltages are often on the order of microvolts. Okay, this is about the thermocouple which I have done earlier. So, the first thermal detector we are looking upon is the thermocouple. The next one is the thermistor. Thermistor bolometer. Okay, thermistor is nothing but a thermal resistor. So you have NTC type of thermistor, which is nothing but negative temperature coefficient of resistance, and a PTC type of thermistor, positive temperature coefficients. And the thermistors are available in different types like beads, you have small disc type, and you have cylindrical shapes, rod types. You have different types of thermocouples. And these thermocouples being encapsulated with an impermeable material such as epoxy or glass. Right. So this is another temperature transducer. Right. All these things you have studied earlier. So just look at this construction. So look at the diagram of this. A thick blackened tip. So this is a thick blackened tip allows the absorption of radiation which heats the thermistor. And when the thermistor is placed in the Wheatstone bridge circuit arrangement, there will be a change in the whenever the temperature rises, the unbalance of the bridge is being detected. Okay, and the unbalance of the bridge being detected as a voltage, and that voltage is proportional to the amount of radiation. So specifically, these temperature transducers used for IR to detect the IR radiations. Okay, so temperature transducers, so thermal